the inspector is incorrect. The 200 amp service disconnect at the meter center acts as the main disconnect for the entire house. The panel placed within the house is classified as a subpanel. According to the National Electrical Code, often referred to as the NEC, a subpanel is not universally required to incorporate a main breaker. NEC Section 225.31 addresses overcurrent protection, stating that overcurrent protection for conductors must align with the stipulations outlined in this section and Article 240. Delving into NEC Section 240.15, which concerns overcurrent protection, it specifies that the overcurrent protective devices of a branch circuit should be installed in an easily accessible location. This accessibility ensures quick operation, reset, or replacement of these devices. NEC Section 240.21 addresses scenarios where the location is not in sight from the equipment. In instances where the circuit breaker or fuse is not installed within sight of the equipment it powers and cannot be locked or tagged in the open position, a warning sign about potential electrical hazards must be prominently displayed near the equipment. However, despite these regulations, there remains no explicit requirement within the NEC mandating that a subpanel must have a main breaker. Therefore, the inspector's assertion is not accurate. It's crucial to differentiate between a service panel and a subpanel. The service panel, often located at the meter, serves as the main point of connection to the utility grid and contains the main disconnect for the entire electrical system. This main disconnect, rated at 200 amps in example, allows for the complete shutoff of power to the house. On the other hand, a subpanel is fed from the main service panel and distributes power to specific areas or circuits within the house. Understanding the role of overcurrent protection is vital. Overcurrent protection devices such as circuit breakers and fuses are designed to protect electrical circuits from excessive current, which can cause overheating, damage to equipment, and even fires. These devices interrupt the flow of current when it exceeds a safe level. The NEC provides detailed guidelines for selecting and installing overcurrent protection devices based on the ampacity of the conductors they protect. The readily accessible location requirement ensures that these protective devices can be easily accessed and operated in case of an emergency or when maintenance is required. When the overcurrent protection device is not within sight of the equipment it supplies, the NEC mandates a warning sign to alert individuals to the presence of electrical hazards. This precaution is particularly important in situations where the equipment is located in a remote or concealed area. In summary, the primary function of the main disconnect at the service panel is to provide a means of disconnecting all power to the house. The subpanel, while still important for distributing power, does not necessarily require a main breaker. Its circuits are protected by individual circuit breakers. The NEC prioritizes overcurrent protection for conductors and accessibility of protective devices. It's important to note that local codes and regulations may sometimes differ from the NEC. It is always advisable to consult with a qualified electrical inspector or professional to ensure compliance with all applicable requirements. Now let us talk about the NEC a little more in depth. The NEC is not law itself, but it is a widely adopted standard for safe electrical installations. It is updated every 3 years to incorporate new technologies and best practices. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Its primary goal is to protect people and property from electrical hazards. When dealing with electrical installations, it is always best to consult the latest edition of the NEC and to seek guidance from qualified professionals. A licensed electrician is trained to interpret and apply the NEC correctly, ensuring that electrical work is performed safely and in compliance with all applicable codes. Electrical inspections are an important part of the process. Electrical inspectors are responsible for verifying that electrical installations meet the requirements of the NEC and other applicable codes. They look for potential hazards and ensure that the electrical system is safe and functioning properly. If an electrical installation fails inspection, the homeowner or contractor will be required to make corrections to bring it into compliance. This may involve rewiring circuits, replacing faulty equipment, or making other modifications as necessary. The importance of proper grounding cannot be overstated. Grounding provides a path for fault current to flow back to the source, which helps to trip circuit breakers and prevent electrical shock hazards. The NEC specifies detailed requirements for grounding electrical systems, including the size and type of grounding conductors, and the methods for connecting grounding electrodes. Another important aspect of electrical safety is the proper selection and installation of wiring methods. The NEC specifies different types of wiring methods for various applications based on factors such as the voltage, current, and environment. Some common wiring methods include non-metallic sheath cable, armored cable, and electrical metallic tubing. It is essential to use the correct wiring method for the specific application to ensure safety and compliance. Overcrowding of electrical boxes and panels is a common problem that can lead to overheating and potential fire hazards. The NEC specifies the maximum number of conductors that can be installed in an electrical box or panel based on its size and type. It is important to follow these guidelines to prevent overcrowding and ensure adequate ventilation. Tampering with electrical equipment can be extremely dangerous and should only be performed by qualified professionals. The NEC prohibits the installation of counterfeit or substandard electrical equipment. It is important to purchase electrical equipment from reputable suppliers and to ensure that it is listed by a recognized testing laboratory, such as Underwriters Laboratories or Intertech. Regular maintenance of electrical systems is essential to prevent problems and ensure safety. This includes inspecting wiring, tightening connections, and testing circuit breakers. It is also important to replace any damaged or worn electrical components promptly. Many electrical fires are caused by faulty or outdated wiring. If your home has older wiring, it may be necessary to have it inspected and upgraded by a qualified electrician. Arc fault circuit interrupters, or size, are a type of circuit breaker that can detect arc faults, which are a common cause of electrical fires. The NEC requires of size in many circuits in new construction and renovations. Ground fault circuit interrupters, or GFCIs, are another type of circuit breaker that can protect against electrical shock hazards. The NEC requires GFCIs in wet locations, such as bathrooms and kitchens. Surge protectors can protect electronic equipment from damage caused by power surges. It is important to use surge protectors on sensitive electronic devices such as computers, televisions, and appliances. When working with electricity, it is essential to follow safe work practices. This includes wearing appropriate personal protective equipment such as gloves and safety glasses, and energizing circuits before working on them. If you are not comfortable working with electricity, it is best to hire a qualified electrician. Now, let's revisit the subpanel scenario. The absence of a main breaker in the subpanel does not inherently make the installation unsafe or non-compliant. The key is that the subpanel is properly fed from the main service panel and that all circuits within the subpanel are adequately protected by individual circuit breakers. The size of the conductors feeding the subpanel must be appropriately sized for the load they will carry, and they must be protected by an overcurrent device at the main service panel that is sized to protect those conductors. For example, if a subpanel is fed by number 6 American wire gauge copper conductors, those conductors must be protected by a 55 amp circuit breaker at the main service panel. This ensures that the conductors are protected from overcurrent, even if the subpanel itself does not have a main breaker. It is also important to ensure that the subpanel is properly grounded. The grounding conductor from the subpanel must be connected to the grounding electrode system at the main service panel. This provides a path for fault current to flow back to the source, which helps to trip circuit breakers and prevent electrical shock hazards. In some cases, a main breaker may be desirable in a subpanel for convenience. A main breaker allows for the entire subpanel to be easily de-energized for maintenance or repairs. However, this is not a requirement of the NEC in most situations. It's important to also check the local amendments. Local jurisdictions can amend the NEC to include additional requirements. It is always important to check with the local building department to determine if there are any local amendments to the NEC that apply to electrical installations in your area. These amendments can vary widely from one jurisdiction to another, so it is essential to be aware of them. For example, some jurisdictions may require arc-fault circuit interrupters in more circuits than the NEC requires, or they may have more stringent requirements for grounding electrical systems. Failing to comply with local amendments can result in a failed inspection and costly rework. In conclusion, understanding the NEC and local electrical codes is essential for ensuring safe and compliant electrical installations. The absence of a main breaker in a subpanel is not necessarily a violation of the NEC, but it is important to ensure that the subpanel is properly fed, protected, and grounded. Consulting with a qualified electrician or electrical inspector is always recommended to ensure compliance with all applicable requirements. Furthermore, always verify what the local authority having jurisdiction requires for electrical installations.